afternoon, ladies and gentlemen. My name is Philip, and I will be presenting Intelligent Dynamic Lighting System. First off, let me introduce my design group. We have Paul and myself as the hardware team. And we have the code team, which is Jeanette, Summer, and Simon. We still have the same problem from last semester. We're still intent on combating light pollution from commercial and residential external light. And we've got our two-tiered approach to combating this problem. Semester one, we focused on tier one, which was motion tracking. And we've actually completed that and we've demonstrated. This semester, semester two, we focused on tier two, lighting control system, and we've integrated that with motion tracking. So we can track motion and point a light. So here's how this works. We have an array of 7 passive infrared sensors that report to an Arduino microcontroller. From there, the microcontroller determines which one of 3 lamps to turn on and off through relay switching. So we've completed tier 1 and tier 2, and we have a fully functional system that we can demonstrate. We've also replaced our prototype fixture with a permanent sensor array that we've designed on SolidWorks and produced using a 3D printer. Additionally, we've modified the code to make better use of the sensor inputs as well as to improve stability. We've also succeeded in hardware consolidation, and we now have the ability to track motion from multiple sources at the same time. So our future plans from last semester are now a reality this semester. During the duration of our design project, we've tapped into a lot of concepts we've learned in class. Digital systems, analog circuit signal analysis, as well as programming. And we've really gotten outside of our comfort zone with things like CAD design and developing ways to switch relays. Before I take any questions, I'd like to give a special thanks to the mechanical engineering department for allowing us to use their 3D printer. And if anybody hasn't seen what a 3D printer can do, please come by our area and check it out. It's really cool. Any questions? Yes, sir.
Is this for the indoor or outdoor application?
This is for external light.
Does it distinguish between a human being or some animal?
Oh, yes, sir. My cat played in front of this for about an hour, and it did not turn the system on at all. The passive infrared sensors completely ignored it.
What about a dog?
It also ignored a lot of vegetation movement from like the breezes and stuff. So this thing set out in the backyard for a long time, and we tried to get other stuff to trip it off instead of human motion, and it was pretty resilient.
Vegetation doesn't pick up much of the infrared, right?
I'm sorry?
Infrared wouldn't pick up much of the vegetation and stuff.
No, sorry. I think when it did pick it up, it was actually picking up my hand, like shaking branches and stuff. So.
How did you set the threshold between a human, small person versus dog?
The sensors themselves did that.
Okay.
That was all embedded inside these sensors.
Didn't require any input from the team with that threshold as I specified.
The sensors are digital, so they detect motion, and they're really small at a range of about 30 feet, and our array narrows it down to about 50 degrees conical field of view. But the sensors themselves are, I guess, they're tuned. So they have a Fresnel lens that focuses all the infrared energy to the detector, and it says, hey, I've got motion. I'll have logic high, no motion. After a while, logic low, and it's pretty much that simple. So we didn't really do anything as far as that spectral stuff. Does that answer your question?
Yeah.
Sure. Any other questions? Yes, sir.
Did you have to do any PCB design, the printed circuit board?
We did consider that, but what we did is we just went to electronic shop and bought some pre-made boards that we could just wired the traces.
Mark.
Yes, sir.
How does this compare with the commercial system that you can probably, that a lot of security people have this kind of thing?
Well, first of all, we can actually get a rough idea of where motion is at, instead of, oh, hey, we got motion, turn on a light. So, the military has stuff that can track motion, and you have industrial processes that can track motion, but they're really expensive, using like video analytics, FLIR systems. I think we did this for about $130. That includes the sensors, the microcontroller, even printing the array on the 3D printer. So this can detect motion from all over the place pretty much, and do it cost effectively without any big time expenses.
How convenient would it be to have 5 zones instead of 3?
That could actually be very easily implemented by altering the code. We
Yes,
designed the
yes.
code such that we could enter any number of lights and any number of sensors in, and it will be able to adapt to that.
You could do that with software.
Yeah, and now it can detect, the sensors can detect up to 13 zone. We're using 3 lights because it was cheaper, but we can change it to 5 pretty easy, which is not that much.
That would be even more impressive.
Right, so let's thank the speakers and additional